now that we have kind of established how to create a cube and vanishing points, it's time to start talking about other techniques. And this is used in all kinds of different ways, not just for multiplying distances. Even though what you see here is you see a vertical square and plane, and we're ultimately multiplying that vertical plane that same distance. So the point here is that this distance, and if you apply this method, which you start with diagonals, that diagonal gives you the center. So the reason why you do that is it gives you the center. And one thing to note, in addition, is that you can use that to find the midpoint or a midline across this distance. So we don't just guess where that midpoint is. Now, one thing that you could use is you could actually take out a ruler, because this is a vertical line, and in two-point perspective, vertical lines do not foreshorten. Only these horizontal lines that go towards the vanishing point foreshorten. But you could measure that, and this should be the midpoint of this, but there are other times when you have a horizontal plane where you can't just measure it. But that gives us a midpoint, gives us the center of that square, which we can then take a line from the center towards that left vanishing point that's out in space. And what you might notice here is that we don't have, the vanishing points are not on the page, and so we have to somewhat imagine where that point is. But step one is to find the center. Step two is to take a line to that vanishing point through that center point, which actually gives us a midpoint here, and here, and here, and here. But of course we may not have drawn those lines yet. And then you can go from one of the corners, it doesn't matter which one, through the midpoint of the far line, and where it hits this top vanishing line basically gives you this distance again. So if this distance is x, that distance is x. And this, of course, is 1/2 x, 1/2 x. But if we were to take a ruler and measure this distance right here, you can see that those are not equal because of the foreshortening. And you can see with this foreshortening how this that square surface starts to look more and more like a rectangle as it moves towards this vanishing point, as it's foreshortening. So let's apply that down here. This is a note that's part of your homework, so we'll talk about that in a minute. But what we want to do is we want to multiply surfaces A and B out to the right. And then C, we'll go up one. And we'll do a couple of other things along the way. So step one, connect the corners with diagonals. And I will tell you that precision can make a pretty significant difference here. I've missed that point slightly, and so I'm actually going to redraw that. And that gives me this point right here. And so again, as I mentioned up here, the vanishing point is not on the page. And so you just have to kind of imagine where that is. And thankfully, we've got some other lines that are running through there that help us with that. If I look at this, this is about, 3/5 of the way up. This would be about 3/5 of the way up on that line. It's just a way to guesstimate. And I can draw that line through there. And so now what that has given me is it's given me that point. Which I'm going to go from this corner through that point. Again, I could go up or down. I could come back through this point. If my plotting is accurate, then a vertical right here would give me, it should connect right there. Not 100% accurate. But that, in theory, is multiplying that distance, whether it's a square or a rectangle. One way to think about this is if this was a sidewalk or something in space, and you're just repeating it as it moves down and away from you, going towards that right vanishing point. So we'll do the same thing here, just to show you that it works with an elongated rectangle. And this is an instance where you could not measure that, right? Because I couldn't just take out a ruler. I could here. I could take out a ruler and measure this and then divide it by 2 to get that point. But here I can't do that because I've got foreshortening going on both of those, in both of those directions. Now I need to draw a line towards the right vanishing point. I'm imagining it out in space. Let's see how that looks. Let's get a little closer to that center point. I'm looking to see if those converge evenly. That looks pretty good. Now I'm going to go through that point right there. Multiply that distance. And where it hits this, I have to be careful not to, when drawing this line towards the left vanishing point, I have to be careful not to mistake these 2 diagonals that I put in there as my vanishing lines. Vanishing lines are on the page already, just to reinforce where they are. That's a vanishing line. This is a vanishing line. And so it's converging a little bit quicker going towards the left than it is the right. So there's that distance. So for this one, on C, we're going to take it straight up. And, I did put this in here, obviously, because I'm multiplying that distance. We talked about it here. I could literally measure this, take that ruler, measure it straight up, and I would get this accurate. But we're talking about this technique that can come in play in all kinds of different ways, and we just so happen to be in 2-point perspective, and we're multiplying this distance vertically. Is the only reason why that would work here. So I'm going to draw a line straight up and down through that center point. I found this point. So now let's go this way. From down there through that point, corner through midpoint, up to here. And that gives me that multiplied distance. Be careful with that top edge and make sure, which will probably be somewhat difficult for everybody, make sure you've got it converging enough. You know, you're looking at convergence towards that left vanishing point. Something like that.